For today's lesson, we are going to learn about similar polygons part 1. Our I can statements for today is for you to be able to say, I can list corresponding parts of similar figures. So similar is a new vocab word. We've already learned about how to list corresponding parts of congruent figures, and the idea of listing corresponding parts of similar figures is very similar. It's basically the same thing. And I can write a statement of proportionality. So we are going to learn what a statement of proportionality is all about and determine whether two figures are similar. So we will make a decision, yes or no. These two figures are similar and what it means for two figures to be similar. For today's lesson, I need you guys to have the following. You will need to have, of course, some color for emphasis, glue stick, and that's going to be for your cutouts that you will need. These cutouts had numbers next to them. We will be putting the numbers into our notebook when we get to that section, and you will need something to write with. So please go ahead and make sure that you have all of these materials before getting started with today's lesson. Let's go ahead and start off by defining what it means for two polygons to be similar. So similar. If two polygons are similar, they need to have the following rules. Number 1, the corresponding angles of the figure must be congruent. So the corresponding angles must be congruent. So there's going to be similar figures. We'll have angles that match up with each other, and those angles that match need to be congruent. So all angles are not congruent, but matching angles will be congruent. And the second characteristic of similar figures is that the corresponding side lengths, remember, corresponding represents the word matching. Corresponding side lengths are proportional. And I'm going to talk about what proportional means in just a moment, but they are proportional. So similar figures essentially are two shapes or two figures that have a similar shape. So that's what this first one means, is that they have the same shape, but they likely have different sizes. So similar figures have different shapes and similar sizes. And different sizes. So what that looks like is something like this. Let's say that I'm talking about a triangle. I can draw the same exact shape, but just a different size. Their corresponding side lengths will be proportional, meaning that all of the fractions, so what proportional means is this. So we know that all of the angles, corresponding angles, will match up and be congruent to each other. It's just that the side lengths are going to be different. So we're going to see that all of the side lengths will be different lengths, but the angle measures will be congruent. The side lengths will be what we call proportional. And what proportional means is that all fractions reduce to the same number. That number is what we call scale factor. And we talked about scale factor back in the beginning of the school year. Scale factor, as you guys recall, was what we talked about when we were working with dilations. We needed to identify what figure or what side length came first and compared it to what came second. The same thing, the same idea of scale factor is what we are going to use with similar figures. So scale factor is represented by the letter K, and it is equal to a fraction. It is a fraction of your second image, a length from your second image, divided by your first image, which we call the pre-image. It's about what came second divided by what came first. This is something that we talked about back in the beginning of the school year. And we are going to be using it again. So if we were to match up all of the sides and give something like this is 3 and excuse me, we'll make this 8, sorry, this is 8, this is 6, and this is 10. And this length right here is 4, this length right here is 3, and this length is 5. All of your side lengths would be proportional. So let's say that we took and we matched up our sides and we were consistent. We said we're going to put 10 divided by 5. This is going to be equivalent to 8 over 4, which would be equivalent to 6 over 3. And all of these numbers were reduced to the number 2. And number 2 would be your scale factor. This is an example of what scale factor is and what proportional is. It is a ratio of all of your side lengths, all of the corresponding side lengths. And when you write all of their ratios, all of the fractions will end up equaling the same reduced fraction. And in this case, it would be the number 2. So what you're going to see in homework is they're going to ask you to verify or show that 2 polygons are similar. That's what the directions are going to ask you to do. They're going to ask you to verify or show that 2 polygons are similar. So how do you do that? Well, that means that you will have to, number 1, determine whether the polygons are similar. So in order to determine whether the polygons are similar, you have to look at the scale factor of corresponding sides. So in order to determine whether the polygons are similar, you must look at the scale factor of the corresponding sides and ask yourself, are the scale factors the same? If the answer is yes, then the 2 polygons are similar. If the answer is no, then the 2 polygons are not similar. The second thing you also want to make sure that you look at is you want to make sure that all corresponding angles are congruent. That is absolutely important as well. So if you are asked to verify or show that two polygons are similar, first thing you need to do is you need to determine whether they are similar by looking at their scale factors and asking yourself the question, are the scale factors the same? If the answer is yes, that means that the side lengths are proportional. The two polygons are similar and we have proportional side lengths. If the answer is no, then the two polygons are not similar at all. The other thing you want to make sure that you look at are the corresponding angles. Make sure that those corresponding angles, the angles that match with one another, are congruent to each other. This is also very important. Sometimes you are going to be given a similarity statement. Sometimes. And a similarity statement is something like, sometimes, I'm going to write this. So sometimes you are given a similarity statement. And that statement looks very similar to what we experienced before. A similarity statement would be something like triangle ABC is similar to triangle DEF. And this symbol right here looks like a tilde. And what that tilde means is the words is similar to. So the tilde means the word is similar to. So sometimes this is going to be given to you, and this is known as a similarity statement. Very similar to a congruent statement. When we had congruent statements, we would say that triangle ABC was congruent to, but the piece that's missing is the equal sign underneath the word, the similar symbol. So that's what makes this similar, but we're used to triangle ABC being congruent to triangle DEF. Now, what's really cool is we've already learned about this before. In a statement, it's all about matching. Angle A would still be congruent to angle D. Angle B would still correspond with angle E, and they would be congruent. Angle C would correspond with angle F, and they would be congruent. But your side lengths, like AB, would not be congruent to DE. Instead, their fraction, their ratio of AB divided by DE will be equivalent to all of the other side lengths, like BC over EF and AC over DF. All of these side lengths, their ratios will be equivalent to each other. So this is an example. I'm going to go ahead and flip the page. This is an example of a type of problem that you're going to see. What I would like you guys to do is at the very top of your paper, I would like you to take the figures that you cut out, and I would like you to go ahead and paste these into your notebook. So I'm going to go ahead and paste this first one at the very top. And we're going to give it the labels that we had originally on our paper. And in this figure, you were told that this side right here is J, K, L, and M. And over here we have A, B, C, and D. And what you are also given in the pictures were side links. So J to K is 14, K to L is 21, M to L is 14, and J to M is also 14. Over here, we are told that AB is 8, BC is 12, DC is 8, and AD is 8. And we are told that we want to determine whether or not, so we want to determine whether JKLM is similar to ABCD. That's what we want to do. We want to determine whether they are similar to each other. So in order to determine, deciding yes or no, the first thing that you need to do is you need to check all corresponding angles are congruent. So let's go ahead and match. J would need to match with A, and I see 2 arc marks and 2 arc marks. K would need to match with B, and I see 3 arc marks, 3 arc marks. L would need to match with C, and I see a right angle symbol and a right angle symbol. And M would need to match with D, so according to our statement. And I see 1 arc mark and 1 arc mark. So far I can say yes, all of the corresponding angles are congruent. But that isn't enough. You need the second piece, that we need to check that all corresponding sides are proportional. So what that means is we need to look at, let me go back and write this out really quick. So we need to check that all corresponding angles are congruent. So in terms of my angles, which is step number 1, I'm going to write this out, that angle J is indeed congruent to angle A, and angle K is indeed congruent to angle B, and angle L is indeed congruent to angle C, and angle M is congruent to angle D. So I'm just writing out what I already know. So that is the first thing that I needed to do, was I needed to verify my angles, and I already see that. So I'm going to put a very lovely check mark that I've already checked all of my corresponding angles are congruent. And now the second thing that I need to do is I need to check that all corresponding sides are proportional. So how do you do that? Well, you need to have an order in order for us to really work with scale factor. And when you're looking at a similarity statement, we're saying JKLM is similar to ABCD. That's what we need to check. So JKLM will have come first, and ABCD will have come second. So that's what we are going to say in terms of this order. I'll always let you know what your order is whenever we are working with problems. So in this problem, I'm going to put a number 1 in JKLM and a number 2 in ABCD. And remember that whenever you're checking scale factor and proportionality, it's all about what came second over what came first. So remember that. K is all about what came second divided by what came first. So with us checking our proportionality, we are going to be looking at sides. So I'm working with JK compared to AB. JK came first, AB came second. So I need to look 8 over 14. What does 8 over 14 reduce to? So once again, I have this is AB over JK. And it's equal to 8 over 14, and 8 over 14 reduces to 4 over 7. So now I need to look at KL and how it compares to BC. So KL is 21 and BC is 12, and it's all about what came second over what came first. So I need to look at BC over KL. BC is 12 and KL is 21. 12 and 21 are both divisible by 3, and 12 divided by 3 is 4, and 21 divided by 3 is 7, so it reduces to 4/7. I need to keep going though, and I need to look at LM and how it compares to CD. It's all about what came second over what came first, so I need to look at CD divided by LM. So CD, once again, is 8, and LM is 14. And we know that 8 over 14 reduces to, or simplifies to, 4/7. And finally, we have JM, and we want to compare it with AD. And remember, it's all about what came second over what came first. So I'm going to be looking at AD divided by JM. And that is, once again, 8 and 14, 8 over 14. And 8 over 14 simplifies to 4/7. So every single one of these fractions reduce to 4/7. And because they reduce to 4/7, what we can say is that the side lengths are proportional. So I can put a check mark. Since I have determined that all corresponding angles are congruent and the corresponding side lengths are proportional to each other, since I have check marks on both of those, I can say yes. JKLM is indeed similar to ABCD. This is called a similarity statement. That's where you name the figure and you say it is similar to another figure. So the answer in this case is yes. This is a similarity statement. Our scale factor in this problem was the letter K, and every single one of these ratios simplified to the same exact value, and that value was 4/7. So in this problem, our scale factor is 4/7. So you might be asked to identify a scale factor, and that is what all of the corresponding side lengths, their proportions, will simplify to. Finally, whenever you are talking about a statement of proportionality, a statement of proportionality is a proportion that uses all side lengths. More specifically, uses all corresponding side lengths. So what that looks like is, you know how I had right here, like AB over JK, BC over KL, CD over LM, and AD over JM? When you take all of those fractions that have all of the letters in them and you set them equal to each other, that is known as a statement of proportionality. So simply AB over JK being equal to BC over KL being equal to CD over LM being equal to, finally, AD over JM. This is known as a statement of proportionality. It's where you take all of your side lengths, your corresponding side lengths, write fractions, be consistent. Notice that I have ABCD information up top and JKLM information down below. Using the correct information, this is, or the correct or consistent ordering of my letters and consistent ordering of my fractions, I now have myself a statement of proportionality. So you're going to see some directions that's going to ask you to identify or the statement of proportionality. This is what you will write. You will be asked to identify the scale factor. This is what you will write. You'll write a fraction. You'll need to make sure that you understand which figure came first and which one came second. And if you need clarification, I would be more than happy to clarify which one came first and which one came second. And then remember that in order for you to determine whether or not two figures are similar, you need to first verify that all corresponding angles are congruent to each other and all corresponding side lengths are proportional. This is very important. Please make sure that you study the language of how to determine whether or not two figures are indeed similar to each other, because that is going to be a question that is on your quiz. That is the end of today's lesson. If you have any questions over anything I talked about, please feel free to email me. Otherwise, I hope you have a wonderful day.